We are back to type classes. I'm Daniel, and in this video we'll switch gears and add the power of implicits in our type class pattern. Alright, so in the previous video we've implemented our simple serializer as a type class. Now in this video, as a part 2 of the type class pattern, we will provide implicit type class instances by implicit values and parameters. So let me show you what I mean by that. So here is the part 2. And here I'm going to add a companion object to this type class called HTML serializer. And I'm going to add a serialize method which takes a type parameter t and a value of type t. And this guy will receive an implicit parameter. I'm going to call this a serializer as an HTML serializer of type t, and this will return a string. And as the implementation, I'm going to simply call serializer.serialize value. So if, for example, I declare an object, let's call this int serializer, which serializes just ints to HTML. Not too useful, but it serves as an example. So let's call this int serializer, which extends HTML serializer of type int. Okay, and inside the serialize method, we will just return some kind of div with, let's say, style color blue. I'm not even sure this is correct CSS syntax, but I'm just going to go with it. And I'm just going to inject the value inside, and then I'm going to close the imaginary div. Now, if I print line, for example, HTML serializer.serialize with the value 42, and I pass it the object in serializer, then this will be all well and good, because I will call the inSerializer.serialize method, and I'm going to return this div style color blue, the number 42 inside. But why not make the compiler figure that out for me by making this object implicit and omit this altogether? So I can say HTML serializer serialize 42, and the compiler will figure out, okay, this is an int, then I need the implicit serializer as an HTML serializer of type int. Oh well, I found one as an int serializer, and then I'm just going to call that. So if I run this again, this will run just as fine. The big advantage of this design is that at the end we can simply say HTML serializer.serialize whatever value, and having defined some implicit objects, the compiler will fetch them out for us. So if, for example, I define an implicit object, implicit of course, proper spelling, user serializer, but wait, I think I have quite a few. We have object user serializer, which HTML serializer user. I'm not going to create another one. I'm just going to make this guy implicit. Then I can say print line HTML serializer dot serialize John. So if I run this, I'm going to see the same div again with the John. That's because the compiler figures out that John is a user, so it searches for an implicit value which is of type HTML serializer of type user. Well, we've defined one right above implicit object HTML serializer user, so it's going to inject that object here in the second parameter list. So it's going to call the serialize value on that implicit serializer. So the advantage of this design is we can simply say HTML serializer.serialize any value for which we have defined an HTML serializer as an implicit object. An even better design is to have inside the HTML serializer companion object a simple factory method called apply, which takes an implicit serializer of type t, and let's add the type parameter here, and it just returns that serializer. So it basically makes the compiler surface out the implicit value for an HTML serializer of type t. And if we then say print line HTML serializer of type user dot serialize John, then it has the same effect in that we are going to see the same div printed out. But the advantage here is that with this design, once we say HTML serializer of a given type, we then have access to the entire type class interface. So not only to the serialize method, but maybe to other methods as well. So we have access to the entire type class interface. So in our little type class template, we can add a small companion object called myClassTemplate and a small apply method of type t, which surfaces out an implicit instance, which is of type myTypeClassInstance of type t, and it just returns that instance. So that when we later use our type class, we can simply say myTypeClassTemplate.apply, or simply myTypeClassTemplate with our little type parameter, and this surfaces out the implicit instance that we wrote, and then we can use its entire interface. Maybe we have 10 methods inside, we can use them all. So let's practice this. I want you, as an exercise, to implement the type class pattern for the equality type class. So pause the video now and follow the example that we wrote for HTML serializer and apply that to the equal type class that we wrote in the previous video. Okay, so I hope you did that. The exercise shouldn't be really too hard. We need to create a companion object for equal and have an apply method for it, which takes a type parameter t, and this takes two values of type t and an implicit equalizer. Let's call this equalizer, which is of type equal t. This will return a boolean, and the implementation is going to be simply equalizer.apply for a and b. And next we would make one of these equality type class instances an implicit object or an implicit val. And if you want to make both an implicit val, you would need to package them separately, because otherwise you would confuse the compiler. For the sake of example, I'm just going to make one of them implicit. And then I should be able to say val, let's say another John, equals user with the same name John. And let's say he's aged 45 and his email is another John at rockthejvm.com. All right. Then I can simply print line equal dot apply John and another John. And if I right click and run this, I should be saying true, because this implicit name equality just does apply with the name comparison. If I make the other one implicit, let's say the full equality, then I'm just going to see false to the console. Okay? So let's make this back. So we can say equal.apply. Now, of course, I can simply delete this and just call equal like it were a function, because apply is special, as we know, and we should see the same results to the console. Now, this case right over here is an example of what is often called ad hoc polymorphism. Simple class polymorphism doesn't allow us to achieve this functionality, as was the case with the HTML serializer we wrote at the beginning of the type class intro. We achieve polymorphism in the sense that if two distinct or potentially unrelated types have equalizers implemented, then we can call this equal thing on them regardless of their type. So we have equal on users, for example, and if we have an implicit equalizer for some other type, we can still call equal on those types as well. This is polymorphism because depending on the actual type of the values being compared, the compiler takes care to fetch the correct type class instance for our types. Alright, so far we've seen three parts of the type class pattern. We've seen type classes themselves, what they are and how they work, and we also saw type class instances, which are the various implementations of type classes on specific types. And in this video, we've learned how to use the power of implicits to make the compiler fetch the right type class instances for our use cases. Now, in the next video, we'll take on the fourth and most fun step in the type class pattern, type enrichments. I'm Daniel, and I'm waiting for you there.